Let's learn how to graph reciprocal functions. We're going to graph two different parents. We'll graph them using transformations. They will use asymptotes. And then we'll describe the end and the asymptotic behavior. So that will be new. We'll state the domain and range with interval notation. Let's get ready. You're going to need notes, pencil, need a calculator to get these shapes. And then you're going to be asked to graph your calculator first. So pause it, take time to make sure you get the same graph. For our reciprocal parents, we're going to look at y equals 1 over x and y equals 1 over x squared. So I ask what do you notice, and hopefully you notice that one of them is squared and the other is not. But if we think about this, now we have x's in the denominator, and we don't want our denominator to be 0. So in both cases, x can't be 0. Here are what the graphs look like, and we would have arrowheads, so we want to make sure when you're actually graphing them, you're putting arrowheads on there. And we said that x can't be 0. So if x is 0, it would be this vertical line. So we're going to have an asymptote there, and y will never be 0 either. So we're going to have two asymptotes. The same thing works on y 1 over x squared. We're going to have an asymptote there and an asymptote there. Notice in the 1 over x squared, both branches go up. I kind of refer to this as the volcano. In the first one, our branches are in quadrant 1 and 3, and the second we're in quadrant 1 and 2 for the normal parent graphs. So we'll have asymptotes, and the asymptotes are going to help shape our graph. So this asymptote is going to form this line here. We will see some of parts of our graphs will go through the asymptotes, and that's okay. The asymptote may be there to form another part. And here we have 1 over x squared. We could do a table of values. We could plug in 1, we'll get 1, etc. And then you can see if we start to plug in bigger numbers, we're getting smaller and smaller, and we're approaching 0, but never reaching 0. So let's look at what our letters do. And you notice we have the same A, H, and K that we've had all along. So our A is going to make it stretched or compressed. If it's negative, it's going to be reflected over x. The h is in the grouping. Our grouping in rationals is in the denominator. So that's going to go left or right, and it's going to go opposite. And then our k is our shift in y, and it's going to go up and down. So here we have this, and I'm asking you to graph this. So I want to think about my shift. This is going to go to the right 2. This part's going to make it go up 3. I want to start with my asymptotes, because what happens is those shifts become your asymptotes. So I'm going to go to the right 2, and I'm going to have a graph at 2, an asymptote at 2, and I'm going to go up 3, and I'm going to have an asymptote at 3. My parent graph would normally go through 1, 1 and have a branch there, and go through -1, -1 and have a branch there. So those are the points that we're moving. So I would have started at 1, 1. Now I'm going to go to the right 2, 1, 2, and up 3, 1, 2, 3, and I end up there. So that's the point 3, 4, and I will have that branch which follows my asymptotes. I would have a piece down at -1, -1, but I'm going to shift to the right 2 and up 3, and then I have that piece which is at 1, 2. And again, you can get some more points for your graph by doing a table of values. So I have my asymptotes. My vertical asymptote is x equals 2. My horizontal asymptote is y equals 3. Remember, they are equations, so you need to write the x equals and the y equals. For my domain, we're going to use interval notation. So I'm reading left to right for the x. So we are -infinity to 2, not included, and then 2 to infinity. And for my range, start at the bottom. We're at -infinity going up, up, up to 3, not included, and then 3 to +infinity. And there we have all of those properties with a beautiful graph. We want to describe the end and the asymptotic behaviors. So we've done end behavior before as x approaches positive infinity, etc. And now, because we have busier graphs, we really need to consider where those arrowheads are. So here I have 4 arrowheads, which means I'm going to have to describe all 4 of them. So as x approaches -infinity, y is approaching 3. It's getting closer and closer to 3. For this arrowhead, as x approaches Now, it's not approaching positive infinity, it's getting closer and closer to 2. But we have this one down here, and then we have this one up here, and we have to decipher between those. So we have to say from the left. This is approaching 2 from the left. So that notation becomes 2 from the left. It's a superscript, it's like an exponent, but it's just a negative, and that means from the left. Then I can finish that, and y is approaching negative infinity. So now I want to do this one up here. As x approaches 2 from the right, that's a plus, then y is approaching positive infinity. And I want to do this last tail. I usually do all my tails left to right. As x approaches positive infinity, y is approaching 3. So these two are approaching asymptotes, and up and down are also approaching asymptotes. Oh, I guess these ones are and asymptotic. So when you're describing the asymptotes, from the left gets a negative and from the right gets a positive. Here's a challenge. So first I'm going to draw in my asymptote so I can see where they're at. So that one's going to be at -3. And I have one at +1, and looks like I would have one at 0, which I do. Notice this green piece in the middle, I call this the spaghetti piece. It goes through it. So here's an example where the horizontal asymptote is really shaping this piece and this piece, and the middle piece is more formed by the vertical asymptotes. So I'm going to have 6 arrowheads that I have to describe here. And again, I'm going to go left to right. So the first one, as x approaches negative infinity, y is approaching 0. My second one, as x approaches -3 from the left, that's going to take a little getting used to writing and seeing, y is approaching negative infinity. This top one, as x approaches -3 from the right, y approaches positive infinity. This bottom one, as x approaches +1 from the left, y is approaching negative infinity. This top one, as x approaches 1 from the right, y is going to positive infinity. And my last one, as x approaches positive infinity, y is approaching 0. There it is, all written out. And to recap, you need to be familiar with your parent function. So this is the parent of y equals 1 over x with our points at 1, 1 and -1, -1. 1 over x squared has points at 1, 1 and -1, +1, and looks like the volcano. You'll be graphing transformations. Make sure you dot in your asymptotes, and you'll be asked to describe the end behaviors and the asymptotic behaviors. Good job.